Hello everyone. In today's video, I'm going to find out the minimum and maximum value of one fractional expression with multiple variables. Here comes the question. A, B, C, D are four positive integers. A plus B equals C plus D equals 25. Find the mean and max value of C over B plus D over A. Before I go ahead, I notice that A and B are two interchangeable parameters in this question. If A and B are switched, it does not affect the result of this question. So, without the loss of generality, I assume A is the larger one between A and B. Since A plus B equals 25, it's easy to find out that A is in between 13 and 24. And let's go back to this expression. There are four unknowns here, but in reality there are only two variables, because if A is fixed, then the value of B is fixed as well. The same situation applies on C and D. But still, if we need to deal with two unknowns at the same time, it becomes impossible. So, at the first step, I treat A and B as parameters, but only C as a variable. Then, this expression becomes a function in terms of C. I write down it here. Fc equals C over B plus 25 minus C over A. And I put C together, then Fc can be further written as 1 over B minus 1 over A times C plus 25 over A. So what's that? This is a linear function, and its slope is 1 over B minus 1 over A. Since A is larger than B, based on our assumption, then 1 over B minus 1 over A larger than 0. That means Fc is a linear function with a positive slope. So Fc is strictly increasing function. As a strictly increasing function, Fc reaches minimum when C is at its lower end, which is 1. And Fc reaches maximum when C is at the upper end, which is 24. So, in this step, we have found out the value of C when the entire expression reaches a mean and max. The next step is to find out the value of A when the entire expression reaches mean and max. I'll work on the max first. Step number 2. In this step, C is fixed at 24, and A is treated as a variable. Then, the entire expression becomes a function of A, and I'm writing down here. GA equals 24 over 25 minus A plus 1 over A. And A is a number between 13 and 24, and it's an integer here. This expression can be further written by taking the common denominator. So it is 23A plus 25 over 25 minus A times A. Similar to what I did before, I'm going to check if GA is strictly decreasing or strictly increasing. By the way, this is called monotonicity analysis. First of all, the numerator 23A plus 25 is a strictly increasing linear function. And the denominator 25 minus A times A is a parabola. Within the range of 13 and 24, it is strictly decreasing. In fact, this is graph, and The blue area shows how it looks like between 13 and 24, and apparently it's a decreasing function here. Then GA is a strictly increasing function divided by a strictly decreasing function, which results in a strictly increasing function of GA. Then GA reaches its maximum value when A is at its upper end, which is 24. And by plugging 24 into this expression, we can get the maximum value of GA equals 24 plus 1 over 24, which is also the maximum value of the entire expression. The next step is find the minimum value of this expression. Similar to what I did in step 2, I treat A as a variable and C is fixed at 1. Then the expression becomes another function of A. Let's write down here. HA equals 1 over 25 minus A plus 24 over A. If we do another monotonicity analysis, the result is inconclusive. So we have to find another way to find out the minimum value. There are different ways of doing so. Here, I'm going to introduce the Cauchy-Schwarz inequality. If you are not familiar with this one, it says for any given number u1, u2, v1, and v2, there is u1 squared plus u2 squared times v1 squared plus v2 squared is no less than u1 v1 plus u2 v2 squared. The equal sign holds when and only when u1 over v1 equals u2 and v2. To apply this inequality to find the minimum value, the key is to carefully choose u1, u2, v1, v2 so that among the three expressions in the brackets, 2 becomes constant, leaving variable in only one bracket. For example, in this case, I'm going to choose 1 over 25 minus A as u1 squared, 24 over A as u2 squared, and 25 minus A as v1 squared, A as v2 squared. Then v1 squared plus v2 squared becomes 25 minus A plus A, which is 25. It's a constant. u1 v1 becomes 1, and u2 v2 becomes square root of 24. That means u1 v1 plus u2 v2 becomes another constant. So from here, by applying this inequality, 1 over 25 minus A plus 24 over A is no less than this value. Let's write down here. Our target is look for the value of A. Remember, the equal sign holds when u1 over v1 equals u2 over v2, which is the square root of 1 over 25 minus A over the square root of 25 minus A equals the square root of 24 over A over the square root of A. This equation can be further written as 1 over 25 minus A equals the square root of 24 over A. And the value of A can be calculated from here, which is approximately equal to 20.7. This is the minimum value of HA and the value of A when we don't consider that A is an integer. By the way, The minimum of HA and its corresponding A value could also be found by taking the first derivative test and the second derivative test. You can give it a try yourself. But we know that in this question, A is an integer. So HA could reach its minimum value when A is an integer close to 20.7, which is either 20 or 21. Then the rest become fairly easy. We just need to plug 20 or 21 into this expression. H21 equals 1 plus 2 over 5, and H21 equals 1 plus 11 over 28. And H20 is larger than H21 by simple calculation. Since we are looking for the minimum value, it is H21. So, in summary, we have found both the minimum value and maximum value of the expression. The minimum value is 1 over 4 plus 24 over 21 equals 1 plus 11 over 28. And the maximum value equals 24 over 1 plus 1 over 24 equals 24 plus 1 over 24. This question got resolved. And at the end of this video, I would like to put a brief summary here. So this video deals with looking for the minimum and maximum value of an expression. There are different methods to do that. First one, check the monotonicity of a function. Second, conduct first and second derivative test. And third, make use of inequality relationships. And if the expression includes more than one variable, we could process one variable at one time by temporarily treating others as constants. That's all for today's video. Thank you.